Welcome back, everybody. I hope everyone had a good Valentine's Day. One thing I wanted to talk, so I handed back some of the exams. If you didn't get yours, please let me know. Or come before class or after class and pick it up. I want to talk about the problems, like the how things are set up. So on each problem, you should have like a score, like 7 out of 10 or something like that, and that's usually circled. I usually circle the things that are the scores of the problems. Sorry, what's the name? What's the name again?
Huh?
What's the name again? Right. So I usually do that on each problem, and then at the very bottom of each page, I don't like usually on the left or the right side, there's a number. Let's just say like 16 or 18 or 20 or whatever like that. Make sure that the problem, so like the other one should have been like a 9 out of 10. So 7 plus 9 is 16. So make sure that those scores that are on the page actually correspond to the bottom thing. If they don't, let me know. Like if any, like I'm gonna mention several things. If any of these things are off, let me know and I will fix it. Those are easy fixes to do, unless it's a number that's lower. Like if you're supposed to get a less than what you got, don't let me know. Then I have to take it away. I wouldn't anyways, because I made like that's my mistake that I shouldn't have made. But then make sure. So as long as that number is right, then check it on the front page. Make sure that if you got 16 points on page 2, there should be a 16 on the front. And then after that, if all of those things are fine, then add up the total on the home on the cover page and make sure that that number is correct. Because I am human, it is possible for me to accidentally add 1 instead of 10. Like I could be just trying to quickly enter things and then I accidentally miss a 0. It's happened before. It hasn't happened in over 7 years. I think the last time it happened was in grad school. So I guess 10 years ago. But still, I am not infallible, so I can make mistakes. Other thing. Those are easy mistakes to make. These are easy mistakes to fix. Then on problems, if you feel like I graded it unfairly, please let me know. I'm happy to hear you out and hear your perspective. I'd love for you guys to advocate for yourselves and say, like, I think I deserve more points in this problem. The worst thing that I will say is, I'm sorry I can't give points, but here's the reason why I gave you the grade that I did. I will never make you feel bad for asking for those things. That's an important thing to be able to do, is to, if you think you were graded unfairly, speak up. And because it could have been that I was just watching something or listening to something that made me angry, and then I just decided to grade angrily. Like the Seahawks lost a game, everyone gets a 0. I try not to grade emotionally. I don't think I usually. I usually just try to put it away if I'm actually going to be angry or anything. But every once in a while, I do make mistakes. So please feel free to ask. I'm happy to do to work with you on that one. If you didn't do as well as you'd liked, please remember that this is one test score. Like the good news about 120 is it's all isolated. Some things do come up again, like solving equations, like we did with the Pythagorean theorem and stuff. That stuff can come up again and again, but overall, it's mostly just new concepts. So that is good news. So there's no like, this isn't going to necessarily build on something. So if you didn't do as well as this one, it's not the end of the world. No one test score defines who you are as a person. And so I'd like to see where the next exam goes, and we'll take it from there. Just keep our nose to the grindstone. Is ear to the grindstone or nose to the grindstone? What's the statement? Nose, I'm pretty sure. And we'll see how we can go. Any questions on anything here? The one other one that I was thinking about is that if you forgot units at one point, or another, I ended up just writing on the front like a unit issue, and I wrote -1. So I only wanted to mark off 1 point. If I did mark off more, please let me know. and I will give the points right back. But I tried to make sure I only marked off once and only for one unit at one point. I don't think it was worth taking off more than that. So what's the name? Lizette. So. Any questions before we get started? Okay, so we will get started with the next section, which is section 2.3, which is on simple and compound interest. So, starting off with a basic, quote unquote, investment formula. So this is just one of those ones that is not really a formula, but it's implied to be a formula. It's an implied formula, is that the total or future amount is equal to the original / initial amount invested plus the interest accumulated. So if you put $500 in a bank and then you get $10 in interest, you have $510 because it's 500 plus the 10 in interest. The 500 you initially put into the bank plus the 10 that you got in interest. So that is a formula that is not, it's a formula without saying it's a formula. So the original amount that you invest plus the interest is equal to the total amount the total amount at the end of the day. Now we'll start off with simple interest. Simple not to mean easy, but simple in the way it is calculated as opposed to compound interest. So simple interest simple interest is interest, of course, calculated only once during the investment period. I will constantly use investment, but technically speaking, you can also be like, this can also be for a loan. So this could be in the negative direction as well. Like you are giving a loan of $500 and they're going to charge interest on it. Like student loans, that type of thing that has interest charge, like that has an interest charge to it. So these formulas that we're learning apply to both investments that are giving you money and investments that are and loans that are taking away money. I'm just going to use investment though, but it's the same thing for loans. So I is equal to, capital I is equal to P times R times T. That is the simple interest formula. I will provide it. You don't need to have it memorized. Where here, I equals the interest earned lowercase p equals the principal. It's principal here. Principal / initial amount. R equals the annual percentage rate. Which we are now always going to abbreviate as APR because I don't want to write annual percentage rate. It takes too long. And then T, oh, sorry, and as an important note, as a decimal. you want your interest, your APR, you want that in a decimal format. So if it's 2%, you want to use 0.02. If you use you will get some not too outlandish of numbers when it comes to simple interest, but compound interest, if you use the percent form in the equation, you will end up getting some massive investments. Like an investment of $100 over 10 years will end up getting like 2 million, which would be awesome. Love it. Love that was true. But sadly, that's not the world we live in. T is equal to time in years. So I equals PRT. So a note about this formula. This is the simple interest formula. This thing gives you the interest on your principal or your initial amount. The book will say principal. I like to say principal / initial to remind us that this is what we're putting into the thing, whether it be a loan or an investment. That's the initial amount that is put in. Everything else is the interest and stuff. The total amount is later. So note, this formula, or the simple interest formula, only gives interest. The interest. So like when you're using this formula to find like you have a certain amount that you've invested for an annual percentage rate of over the amount of years, you only get the interest that's accumulated on the loan or like on the investment. So to calculate the total / future amount we add our initial amount to it. So total amount equals lowercase p plus I. I'll let you write that down because I wrote that very quickly, and I'll explain what I mean. So the simple interest formula, it only gives us the interest. When you plug everything in, it just gives you how much interest is accumulated. So let's say like you got $55 in interest. If the question asks you for the total amount, that's only the interest. So what you have to do is you have to take your I value that you just got and add P to it. I'll show you some examples in a second. So as an example, find the interest and total amount of an investment of $4,800 over 13 years at an APR of 4.62% in simple interest. Find the interest and total amount of an investment of $4,800 or $4,800 for 13 years at an APR of 4.62% in simple interest. Okay. So I'm going to highlight the fact that it says in simple interest as a giveaway to which formula we're going to use. So as soon as I saw this, I knew I was using I equals PRT. Now, you might be thinking, well, duh, Phil, that's the formula we have in front of us. And I will say, yes, that's true. That is the formula we have in front of us. But how do we, like, if this was a problem on an exam or a quiz, which will have both simple interest and compound interest, how do we know which one to use? Look for the verbiage. If you see simple anywhere listed, it's probably going to be simple interest. See, if you see simple interest, it's definitely going to be simple interest. If you see the word compounded or compound interest, then you know that you're dealing with the compound interest formula. But anyways, that's why I'm underlining it. Yes, it's the only formula we've encountered so far, but there's a reason that I'm underlining it. Yes.
Will there ever be a problem where it's not specified?
No. Yes, it should be always listed, like you'll either see the word simple or compounded.
Okay, so we never have to assume it's like compound if it's not simple.
Yeah, exactly right. So we have I equals PRT. So I'm going to list all of them, I, P, lowercase r, and lowercase t. And we're going to try and list all the ones that we know. Do we know the interests? No, that's the one that it says find. We're going to find the interest. So that's an unknown. P is the initial or principal amount, which in this case would be 4,800 or 4,800. R is usually the nicest one to find. It's the percentage, annual percentage rate. So 4.62%, but we want it in decimal form. So 0.0462, because we're writing it in decimal form. And T will be 13 years. So T is 13. So I is equal to PRT. That would be I equals 4,800 times 0.0462 times 13, which is, if I use my calculator, times 0.0. Yep. $2,882.88 on these problems. So these problems, it's probably always going to be listed that we're going to round to 2 decimal places because that would be the nearest cent. So that's your interest, which is pretty substantial. Granted, it took 13 years to get that. So it took 13 years for you to get roughly about half of your investment in gains. So not great, but not bad. And if you had instead used 4.62% in like if you used 4.62 instead of that, you'd end up getting that the interest that you gained would be $288,000. So this is a thing I like to mention is whenever we're doing these types of problems, especially in finance, because there's usually, I try to make sure that my problems are not are realistic. So you would look at that and say, there's no way that $4,800 magically grows to $288,000 in interest, right? That just seems a little too good to be true. And case in point, we will be going over mortgage calculations in this class. And back when I first taught this at a different college, we did it a different way. We used the formula, whereas here we're going to use something different. And what you'll find out is the mortgage calculating formula is actually very, very nasty. If you've ever seen it, it is, if memory serves, A is equal, you don't need to write this down, but A is equal to P times 1 plus R divided by N raised to the NT minus 1 over R over N. I think that's the formula, which is a very, very long formula, and it's got fractions within parentheses. It's very easy to make a mistake when you're using this calculation. And so I think it's supposed to be A, or Yeah, no, it's this. Where, or I think it's R actually. But R is your monthly payment. And so it's very easy to make mistakes here. And so I told my students, you gotta really look back at your answer beforehand. And not everybody listened. And so on the final, on one of the exams, the question was $400,000 house with an APR of 5% over 30 years. What would the monthly payment be? Standard question for this stuff. And the student got $31 payment, which if you can get that, someone's losing their job at Wells Fargo or what are the other places? Emerald City Bank, whatever. If like someone's losing their job there, don't tell anybody. Don't tell anybody. You're paying $31 for a $400,000 house. So basically, just look at your answers and say like, does this make sense in the context of the problem? And if it doesn't, look back over it. I promise you that all the problems that I put on your exam will be reasonable in their answers. So if you get something like $288,000 for a less than $5,000 investment, that would be an indication that something's wrong. So anyways, that is the interest. I is equal to $2,882.88, but it also asks us for the total amount, which I'm going to use as A, total amount, or I guess I'll just write total amount right now. Total will equal original plus interest. So that would be 4,800, so 4,800 plus that interest of 2,882.88, which ends up being 7,682.88. And we also the one unit that I am very, very forgiving about is the number is the dollar sign. I think we're like one of the only countries that puts our unit like we've already talked about this, right? We've already talked about it. So if you forget the dollar sign, I'm not going to be too picky about it. Once again, maybe 1 point off the total final thing. Okay. Any questions on that? So it only gives us the interest. So if we need to find the total amount, we just take the initial investment and add the interest on top of it. Now that formula, I equals PRT. As we see in this problem, all four of those things are different variables. So different variables, like we can solve for different ones. Here, we didn't need to do any moving. We didn't need to do anything. We just needed to plug in the numbers, multiply them together, and we got the answer. But here's an example of one that's not like that. So how much time is needed for an investment? How much time is needed for $1,500, $1,500 to accumulate $800, $825 in simple interest? At an APR of 11%. Which sadly none of us are ever going to get. An 11% APR is just if it's for a loan, maybe. One to keep us all down. Make sure you can't bankrupt out of student loans. That wouldn't be good. Companies can do that though. They can bankrupt. That's fine. Your company that they help the economy, not the people who actually pay the bills. Anyways, not that I'm bitter about that concept.
It's okay.
You sure? No. Thanks a lot, doctors. Fun fact, that's the reason why they passed that law. The doctors constantly, because medical school cost way too much money, would just go to get medical school, then bankrupt out of it, and then just call it good. Which, yeah, I heard their credit, but they're making doctor money, so they're fine. And couldn't have that happen. We can't let that happen. So thanks a lot, doctors. Okay. Sidetrack. Sorry. How much time is needed? So It says simple interest. That tells us immediately that we're dealing with the simple interest problem. Once again, I know that's the only formula we know right now, but if this was on an exam, you need to be looking out for those key verbs, or not key verbs, key words. So I equals PRT. Identify all of them, I, P, R, and T. So this problem said, how much time is needed for $1,500 to accumulate? So it gives us the principal, the initial amount. And it says to accumulate $825. So that means that your I is 825. That's the amount of interest we want to accumulate. The rate was given at 0.11. So 11%, 0.11. And then time is the unknown here. This is how much time. So I equals PRT, we get 825 is equal to P, so 1,500 times 0.11 times T. And there's a lot of ways we could solve this right now. We could do it the quote unquote natural way, which would be to follow PEMDAS as much as possible and simplify that coefficient in front of the T. So 1,500 times 11, we could do that, which is what I would recommend. So 1,500 times 0.11 gives us 165. So we get 825 is equal to 165 T. Now, sometimes that number won't necessarily be that nice. Maybe it will like you got 165. Maybe it'll be an irrational number, so it'll be an infinite decimal chain. If that's the case, just write out about 5 decimal places. If you're going to round early, make sure you round to a lot of decimal places. Like write as many as you can, because like on an exam, I'm fine with it. I'm fine with you rounding to 2 decimal places if you want to earlier on. I'm okay with that because I am a human and I'm reading your work. Sadly, Canvas is not as forgiving. And so it might, if you round early too much, if you only round like 2 decimal places instead of 5, it might throw your answer off by like a cent or 2. And that would be enough for Canvas to mark it wrong. That being said, if that happens to you, if you do that and it marks it wrong and it shows you the answer is like you wrote 1,500, like write it down. So like if you wrote 1,523.86 and it says that the answer is 1,523.84, just email me and I'll give you full credit back. That's a situation where the rounding ended up slightly changing everything. Yeah, you lost out on 2 cents, but that's just my 2 cents. I didn't even mean to make that joke. It just happened. Anyways, so that is one way to do it. That is the way I would recommend. It's just to take care of the multiplication on the right-hand side first, so that you can then get rid of it, because we're trying to solve for T. We use different color. Let's use pink. So we need to undo that multiplication to cancel it on the right and get the T is equal to 5. Very, very nice. It ended up working out really nicely for us. So 5 years. T is equal to T. I meant to write T is equal to a question mark. Of course, T is equal to T. Any questions on that? All right. Let's see here. This is a slightly different problem, but important to see the difference. So I'm going to do this. So, example. How much time is needed for $750 to grow to $3,000 at an APR of 15% simple interest. Move that to the side for a second because let me move that. Can I move that up or down? Can I move that to the very bottom of the screen? Ooh. Do I like that more? Do you guys like having the thing at the bottom instead? That would allow me to write more at the top, wouldn't it? That might be better. I thought about it. Okay. Getting sidetracked. The big difference here, very, very similar question, but how you approach it is slightly different. Notice that the first one says you want to accumulate $825 in simple interest. It gives you the interest. This one doesn't. It tells you that the $750 is going to grow to $3,000. So solution, I'm going to underline that in, well, that's weird. I can't handle that. 750 to grow to 3,000. From the blue, we want our total / future value. Is that better? We want our total / future value to be $3,000. Since simple interest, since the simple interest formula, that is, the simple interest formula only calculates interest, we need to find that first. We need to find that first because it didn't give us the interest. It gave us the total amount at the end of your investment period. You want that $750 to grow to $3,500. So what's the interest then? So total amount is equal to, don't worry, I'm going to come right back to this. If you're not finished running, it's not a big deal. The very, very beginning, total or future amount, the total amount in your investment is equal to the original amount invested plus the interest. So that is to say, another way to write this is to say the interest is equal to the future amount minus the initial amount. So we take the 3,000 and we subtract off the 750 to find the actual interest on the thing. So that'll be $3,000, the final amount, minus the 750, which is the initial amount, which ends up being $2,250. Does that make sense? Does anyone have any questions on that? Okay. Oh, no. Thank you for letting me know. I'm a little tired today. It's called getting ready for my son's birthday. Having to buy the decorations, and get everything ready.
What theme does he want?
Hot Wheels.
I have a 3-year-old, she loves Bluey, so her birthday party was.
The recent one, we asked him a month ago which one he wanted to do, and he said Hot Wheels because he got a Crisscross Crash track, and also a Mario track for Christmas, and So he's been obsessed with them, but recent has been Paw Patrol. So that song is stuck in my head. Patrol.
Did you know that there's a real life Hot Wheel? Like they actually make the track?
Really?
Mhm.
That's like even the crazy ones.
Even though the cars go on.
Really? Crazy. Went to the monster truck rally at one point, or like the Hot Wheel monster truck rally, and that was it's too loud for him. He's a sensitive kid. He's great though. Anyway, I'm getting sidetracked. I'll talk about my kid forever. Okay, so now we have interest. We have interest, so we now have I is equal to 2,250. Our principal or our initial amount invested is 750. R is equal to 0.11, 15, 0.15. And T is our unknown. So I hope everyone like sees the important implication of taking these questions slowly, reading them for everything that they're saying. So like making sure, is the interest actually 3,000, or are they saying that the interest plus the principal needs to go up to 3,000, that type of thing? So we have $2,250 equals P, which is 750, times R, which is 0.15, times T, which is T, the unknown. That is, if you multiply the right-hand side, you get 2,250 equals 112.5 T. By the way, so one thing you could do is you could divide by 750 and then divide by 0.15, or you could like, some students will do this instead. And this is not wrong. This is what I would do, but this is not wrong either. You could go, I'm going to divide both sides by 750 times 0.15. Because that will cancel the 750s and it will cancel the 0.15s. My only request is that if you do this, you make sure that in your calculator you've entered incorrectly, because we talked about this kind of the second or third day. 2250 divided by 750 times 0.11. The calculator would read that as take 2,250 divided by 750, then multiply by 0.1. So you'd want to make sure you put this in parentheses. Is that okay? Just it'd be an easy thing for me to grade and give most full credit, but Canvas won't really like it that way. So anyways, that is still an option. So what I did in blue there, you can definitely do that. It's not wrong to do so, but I think it would be easier to deal with if you write it as a coefficient, like as a number first. So once again, 2,250 equals 112.5 T. We got to get rid of that 112. So we're going to divide both sides by 112.5. That cancels it on the right and gives us that T is equal to 20. Yeah, totally. Can't handle that. There you go. Any questions on that? All right, we'll do one more simple interest problem. We solve for we solve for I. We can solve for P and we can solve for T. I'm going to do a little bit. I'm going to do a different one. So example. If $4,300 yields $1,032 in simple interest over 6 years, what is the APR? I have a deliberate reason for doing this one, this choice of problem instead of a different one. $4,300 yields $1,032 in simple interest over 6 years, what is the APR? The fact that it says simple interest, once again, gives it away. Gives away which formula we're supposed to be using. And as a reminder, I will provide these formulas. I will write I equals PRT on your exam, whether it be on the last sheet or on the front sheet. I'm guessing it's better if it's on the last sheet, right? Because then you can rip it off and have it in front of you. Is that preferred? Okay. So I equals PRT, solution. You'll see that every single time I'm kind of doing the exact same thing. I'm setting up all my variables and trying to identify them. Fun fact, if this is an exam, let's say this is a 10-point problem, writing that is worth, like writing these things is worth about 4 to 5 of the points. So like just writing it down helps you out. You can set up, you don't have to do it if you know what to do and just go ahead and get the right answer. I'll give you full credit, absolutely. But I'm just saying, like, if you're stumped, you can still get partial credit by writing down all the pieces that you know. And the reason why I'm telling you that is because if you start doing that, you'll find out that if you're not afraid to write down things, you start to realize that as soon as you start writing things down, you get ideas. And your synapses start connecting and giving you ideas on how to proceed. So I is equal to here 1032. The interest that is accumulated is $1,032. The principal is $4,300. The rate is unknown, and time is 6 years. Rate and time are usually the nicest ones to find out. So I is equal to PRT, so 1,032 is equal to 4,300 times R times 6. Now I wanted to do this one particularly because the variable's in the middle. And that might freak you out a little bit, but you have to remember that multiplication is commutative. And the other thing is it's called associative, which means that basically whenever you have a string of things multiplied together, you can jumble it around however you want. You can bring all the numbers together and leave the variables on the outside. So we're just going to multiply the 4,000 times the 6 and get 1032 is equal to, so 4,300 times 6 is 25,800 times R. And if you're looking at this and saying like, oh no, that's going to be a pretty small number, like, is that okay? It is. It is. We'll divide both sides. Yeah, yes, it's a big number, but big numbers are just like you and me. They're fine. They're not scary. They're just bigger numbers. Divide both sides by 25,800. Yes, so 10. Really, it's 0.04. It's exactly that. That's amazing. Usually, like a lot of times, these ones end up being like 0.087532, blah, 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 on and on forever. But this one turns out to be a nice number. That's a very small number, but you got to remember, this is the annual percentage rate in decimal form. So we're going to convert it to percentage form, move it 2 units to the right. So we get that the APR is 4%. The questions, if these types of questions pop up, they'll typically ask you to write it as a percent. So make sure to convert it. Yes, so for the decimal one, you'll probably want to round it to 2 decimal places. That's a good question. So the verbiage will matter here. So if it's it'll probably like what I will ask for is like round your percent form to 2 decimal places. So you'd want to write 4 decimals at least in the percent in the decimal form, so that when you convert it, like if you get 0.127842, you'd want to round to right here because then you'll get like writing it as a percent form, you'd write 12.7842, and then we round to that. So hopefully hopefully they like the question specifies that. And once again, if you round early and stuff on a quiz or on a homework, just let me know and I'm happy to fix that. I'm happy to give you full credit back on that situation. All right. Now on to the other side, which would be compound interest. So compound interest is interest calculated on the principal / initial amount and accumulated interest. Over previous periods. A big double-edged sword, because when it comes to investments, getting interest upon interest is a good thing. But on the flip side, if it's a loan, interest on interest is a bad thing, because now you're getting extra interest charged on you. So in essence, with a compound interest problem, 4% APR is not actually 4% for a compound interest problem. It's usually more like 4.2 or something like that, because you're getting charged interest on the interest already charged. And I'll show you what I mean. I'll give an example. And this legitimately is part of the reason why the rich get richer way faster than everybody else. We're going to do it with a nice number, but you'll see how terrible this can be later. So let's just say you have $1,000 and you invest that and they promise you 5% return in the investments. Then after the first year, so at 5%, after the first year, you have $1,050. We don't need to go through the math of it, but 5% of 1,000 is 50. So at the end of the first year, you'll have $1,050 in there. Now, if it was just 5% every year on the original amount, you'd just be getting $50 each time. But the way compound interest works is now we're going to do 5% of that number. So that's on the initial amount plus the interest that was just obtained. So it's 5% of 10,050, or sorry, 1,050 now, which ends up being $1,102.50. Not a big change. Instead of adding $50 in interest, we got $52.50. So it's not a lot, but let's say that was $1 million. So $1 million times 1.05. So with 5% interest on $1 million, you would end up with now $1,50,000, and then you multiply that by 1.05. And this time you end up getting an additional $2,500. So $2.50, not that big, nothing to be too excited about. That's not even half the Starbucks drink. But $2,500 additional, that's like, granted, if you're able to invest $1 million, that might seem like chump change to you. But anywho, so this is interest upon interest. Next time, you end up with, if you do 5% again, now you have $1,157.63. Technically 62.625, but I'm going to round to the nearest cent. So this time you ended up getting $50 and then you got an additional $5.12. So, or 13 cents actually. So it starts getting significant. Every year it happens, it becomes a little more significant. And that's the reason why the rich get richer. If you have that amount and you just keep it there, since you don't have to spend it, it's just going to get bigger and bigger, faster and faster. It's exponential. Yes.
So this is pretty much like one of the high yield interest bank accounts.
Yes, yes. And so, I'm sorry, what's the name again? Lizette's absolutely right, is that this is kind of like a high yields interest account. CDs operate in a similar way, like, not CDs like that, but, I forget does anybody remember the name for it? Yeah, it's like certified deposit or whatever. Those are like, you can't touch the money, but it's gonna accumulate interest at a higher rate than if it was money that you could touch. And that's the same thing. That is different than saying an IRA. So an IRA is an individualized retirement account or just a 401k or something like that. Those things you put periodic payments. So not only are you getting interest on the amount that you had before, then you're also adding in a payment. So that's adding on more money in addition to the interest, which then gets interested again and again and again. So those are really, really good for the average American, way too good for the super elite. Uh-huh. 6 cents. Yeah. They like as an anecdotal piece there. I remember at one point our like my wife and I, we had our savings and our checkings. And we realized, so we had most of our money in just our checkings. We weren't really putting much into the savings. And so they mentioned, like, we looked at it and said that we had an interest rate on our savings account of 6%. And like that's really large for a bank account. And so we're like, well, shoot, we should just move all our money. As soon as we did that, the next day they dropped our interest rate down to like 1%. So can't be having too much money. Can't be doing too nice. So it's a bummer. That's one of those things that end up one of the great things about being a mathematician. Speaking of which, as a fun little side note of how this stuff actually really appears in real life, because it happened to my wife and I last night when we went out for margaritas. Nothing too crazy, just so we're clear. I was looking at it, and their happy hour menu said 12-ounce margarita is $5. And a 16-ounce margarita was $7.50. And I looked at that, said, wait a minute, that doesn't look right. And unit conversions tell you that it's actually a worse deal to get the 16-ounce margarita. It ends up being per ounce for a 12-ounce, 5/12, it's 41 cents per ounce if you buy the 12-ounce, whereas 7.5, it's 46 cents per ounce for the higher cost. I almost wanted to talk to the manager just to let them know that they like, but I'm assuming that they hope that people haven't taken Math 120 and know their unit conversion. So legitimately, math helps you out here. Just save yourself 5 cents per ounce on your margaritas. Another way you can convince it, like, there's plenty of ways you can convince yourself, but I saw that and I was like, boom, my 120 students are going to eat that up. Because that was a situation where math actually helped you out. Okay, sorry, so the sidetrack. We got plenty of time, good. So the formula. The compound interest formula is a little daunting at first. A is equal to P times 1 plus R divided by N raised to the NT, where A is equal to the future / total amount. P is equal to the initial, the principal / initial. amount. R is the APR once again as a decimal. As a decimal, very important. Way more important than it was for simple interest. If you don't use a decimal, you will get some outlandishly large numbers. And I'll explain why in a little bit. N is on, like, all the variables that we've seen here are all the same. That's the good news, is that all the same variables, but the new variable that's been added to this is N, and N is equal to the number of times compounded per year. And then T is number of years. So A is equal to P times the quantity 1 plus R divided by N raised to the NT. If you'd like to know why the formula works the way it is and why it's set up the way it is, the R divided by N is saying that they're not going to charge you, like, they're not going to give you the interest, the full interest ever. Like, let's say this was compounded monthly. They're not going to give you the full amount of interest every month. They don't give you 5% more interest every month. They give you 5% divided by the 12 months that you are getting it. So that's why it's not exactly that, but it's close. And then N times T, because you're not just doing this interest once every year, you're doing it once, you're doing it multiple times per year. So as a little trick about this, so for this one here, annually, N equals 1. If it says that it's annually compounded, that means it's only compounded once per year. Now, this is the one that always gets me. Semi versus bi. So semi-annual or biannual. I believe semi-annual would mean once every 2 years. Is that correct? I think it's vague, but semi or biannual would mean 2. We never see it anyways. It's not important. But quarterly, N would be 4. So that would be every 3 months they charge interest. Monthly, N would be 12. Weekly, N would equal 52. And then daily, I'm going to say it's 365. Sorry, leap year. If anybody, I still haven't yet to do it. Is anybody born on leap year? Anybody born on the 29th? It's like a unicorn. I've never seen one. Yep. Well, that's so, like, it's cool. So then you're only technically like 15 when you're like 60 or whatever. Super. She's 5. So super cool. We don't count the leap years. In fact, if I remember correctly, our book says that sometimes they make it like 360 instead. And that kind of depends. I'm always just going to assume that daily means 365. And if the homework or quiz makes that an error, let me know. I'll give you full credit back. If you don't know those quantities, by the way, feel free to talk to me. Like, if you read it and you don't remember what quarterly means, just ask. I'm happy to answer that question. I don't want that to be the reason why you're bogged down, or if you don't know how many weeks there are in a year. Yeah, it's a 4. It's a very bad 4, but it's a 4. My wife writes her 4s like that. And I can't stand. I like. She's
a lot of extra work.
Well, I end up writing a 9.
That was my argument to her. But then again, her handwriting is immaculate. It's way too good. So, like, I trust her on that one. I don't trust myself with that. So, okay. Sorry to get sidetracked. Let's go through some problems. Just as a note, in contrast, this one says A equals P times 1 plus R divided by N raised to the NT. So this one gives you the total amount. So if you were asked to find the interest, you now need to subtract the principal. So it's kind of in the reverse order. And I'll give you an example of this. Example. Find the interest for $950 invested for 10 years at an APR of 4% compounded quarterly. So the fact that it says compounded quarterly means that we're going to be doing the compound interest formula. A is equal to P times 1 plus R divided by N raised to the NT. Always a good idea to write it down at least once when you're doing these problems, just to practice it, get comfortable rewriting it. But since it will be provided, as long as you know which one is which, should be fine. But since it says compounded quarterly, we're using the compound interest formula. So let's label everything we need. A, P, R, N, and T. Do we know A? Nope. We don't know it because we don't know what our final amount is going to be. We're being asked to find the interest, which we don't know either, but in order to find the interest, we need to find the total amount and subtract off the interest. So A is unknown. P is 950. That's the amount that we're investing. That's the initial amount. That's why I like to call it, instead of principal, I like to call it initial amount, because I feel like principal is just hoity-toity math talk to make it seem more intimidating than it is. If we say initial amount, it makes it far more clear what we're talking about. So R, the annual percentage rate, already given, 0.04. N is compounded quarterly, so N is 4, and T is 10 years. We have everything we need here. A is going to equal 950 times, in parentheses, 1 plus 0.04 divided by 4 raised to the 4 times 10. Okay, if you have your calculator with you, I want you to practice entering this, because this is something that takes practice to get perfect. If you are using the calculator that I recommended, it should be pretty nice to do. If you're using that one Texas Instrument that looks like this, you know that one? If you're using that one, this is how you have to enter it into your calculator. If you want to do it all at once, you do 950 times parentheses 1 plus 0.04 divided by 4, end parentheses, caret, parentheses, 4 times 10. If you don't put the parentheses in that calculator, like the Texas Instrument one, it will assume that you're like, it'll do something completely wrong. So you should get 1,400, so $1,414.42 when you round to the nearest cent. So if you're not getting that, let me know, and I want to help you find out where your mistake is being made. Because I want you, when you guys are doing your homework, I don't want this to become an issue for you.
So we would have to put it in, we have to put that in vision is our calculator.
Yes. So you should get $1,440.42. If you're not getting that, what's up?
That plus 1 parentheses.
Yeah, so parentheses 1 plus 0.04. So this is multiplied, right? There's a multiplication right here. Is that okay? So it's 950 times parentheses 1 plus 0.04 divided by 4, and then end parentheses.
The little numbers on top. What are they called?
So if you're using, I see you're using my calculator, there's a button that says X, and then there's a little box. That button will put you into the exponent.
And then we just go 4 times the test.
Yes, in that exponent. Make sure you're staying in the exponent. So, nope, you're on the right track. Right?
And then divided by the. And then this one here, or lets you input your own like exponent. So hit that one.
Anybody still having problems? I just don't want you to make this mistake when it comes to like the homework and the exams. Okay?
No.
All right. So as an aside, if you used 4% instead of so if you used 4 instead of 0.04, you end up getting that you would have made on $950 over 10 years. You would end up with $1,044,563,046. Something along that. I think actually even more than that. I think it's in how many is in a trillion? So 10 to the 6th. So 1, 2, 3. 1, 2. That's $1 billion. That's $1 trillion. Right? Under like 1,000, million, billion, trillion. So yeah, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. So this is actually 3 times like 3 more zeros. That's what you would get if you used 4 instead of 0.4. So if you see an insanely large number, it's probably that you used the wrong, you either made an error in your calculator, you entered it wrong into your calculator, or you used the wrong percentage, or you used the percent form instead of the decimal form. So that's what I'm talking about. Those are the types of numbers where you look at it and you're like, that's looking wrong. So John Doe student, silly John Doe, at it again. He boxes this. I give him, it's a 10-point problem. I give him 7 out of 10. Why? That's not the final answer. The final answer is asking for the interest. This is the total amount. This is the total amount, but we want the interest. Which isn't too terrible to do, though. That's the final amount that's going to be in the account. You just take off what you initially invested. $1,414.42, and you subtract off that $950, and you get $464.42 in interest. The interest, the simple interest formula, or the very first formula we said. So, in essence, what I'm doing here, thank you for asking that. It's Komori, right? Yeah. So what's happening is total, which is usually denoted A, equals principal P plus interest I. A is equal to P plus I. So A equals P plus I. And you can see you can solve for any of them as long as you have the other two. If you have the total amount and the principal, you can find the interest by taking the difference. Like you can solve this for all 3 of the variables. If you have principal and interest, you automatically have total amount. If you need to find interest, you just subtract P from both sides, which is exactly what we did here. A minus P gives you I. So any of those ways, anything you can do here. Or if you have the interest and have the amount, you can find the principal. Yes.
So why the interest is the principal?
Oh, excellent, excellent. So the principal is not the, like, so this is the general form. If I solve for interest, then I get I is equal to A minus P, and then it fits into the formula. This is A P. So the version that I originally gave is the general version of it, saying that the total amount should be the interest plus the principal, but you can manipulate that equation however you need it to go.
So about the conclusion, why we're using like 950?
Yes.
Why are we using that?
So that's the principal amount that was invested.
Oh, okay.
Mhm.
So when it's asking for interest, we would subtract the principal amount?
Yes. Yes, when it comes to because the compound interest formula gives you the total amount. Whereas the simple interest formula gave you the interest. So there's this silly duality between the two of them. All right. Would you guys like to do another compound interest problem? I think we have enough time for, I think, one more. That was the end of my notes, but I think we should do one more. Let's do find the total amount of an investment. Someone give me a number. 2,400, perfect. $2,400 at an APR of, someone give me a 2-digit decimal number.
Oh,
Like a two-digit,
well,
2 decimal percentage. 8.75%. Sorry, I wasn't clear about that one. Sorry if you suggested one, I didn't take it. And so find 2,400 at an APR of 8.75% over, someone give me a year amount. 13. 153. It said 5 and 13. No, that's not 153 would be way too bad. That'll give you a very large number. Let's do 15. 13 and 15, 5. Let's do it that way. Over 15 years. Compounded, if interest is compounded. Monthly. So monthly meaning 12, because 12 months in a year. So because it says compounded, dead giveaway that we're using the compounded interest formula. Like as soon as you see that word compounded, don't even bother looking at the simple interest formula, just go to that A equals P times 1 plus R over N. I'm going to underline it and say that again. A equals P times 1 plus R divided by N raised to the NT. But as soon as you see that word compounded, compound interest formula. If you ever see the word simple, assume simple interest formula. I promise you that on my exams, that verbiage will be very clear. If I want you to use the simple interest formula, I will use the word simple interest. Like I will use simple in there. If I want you to use the compound interest formula, I will say compounded. Somewhere in the problem that you can underline and note that's what we're trying to do. So that might be a little bit of a hint, hint, wink, wink, that maybe something like this might show up on the upcoming, the next exam. You know what I'm saying? I got a wink in my, okay. So A, we don't know. We want to find the total amount. So we don't know A. P, we do know 2,400. R is an AP is a percentage, is our APR. So that's 8.75%, but we want it in decimal format. So we will do 0.0875. N should be 12 because it's compounded monthly. and T is 15 years. So T is 15. So A is equal to 2,400 times 1 plus 0.0875 divided by 12 raised to the 12 times 15. And that should be, when you plug it into your calculator, you should get $8,874.72 when you round. That will be the last problem. I want you guys to compute that in your calculator, check to make sure you get it right. This is one of those ones where you just need to know the calculator. Like once you practice it like 2 or 3 times, you'll be a master at it. It doesn't take too long to master it, but I just want to make sure that I catch those mistakes if you're making them already. Okay, so if anybody's not getting that number, please let me know. If anybody wants to borrow a calculator, I've got one up here for a second. Yes.
My 0.719, just assume always round up, right?
Yes, just always round up. Well, 719. So that should round up to 72. Always round to the nearest cent. Did you have a question? Okay. Anybody? You're getting it wrong again? Let me see. By the way, so that was the rest of it. Like, if you still are having struggling with the calculator, let me know and I'm happy to work with you. Otherwise, that'll be it for today. I hope you guys have a lovely rest of your day and a lovely weekend. And I'll see you guys on Tuesday. But